Hello everyone, this is Chuck from Sub-Zero Squirrel. Today I want to talk to you about the Lost Office and how we wanted to make an environment with multiple different objects, with multiple different interactions. And we needed a way to make all of that come together in a first-person, point-and-click adventure. Well, at first I wanted to go with a huge database, so I started writing this gigantic database and realized quickly that I was wasting my time and the resources that were given to us by Unity, and found a way to handle this really quick using game object tags and animations and the ubiquitous get component namespace. So let's just get down into it. So here I have a little world that I've created. Nice fantasy world with a simple terrain, some trees without any branches. We have this sphere here. We have this cube, these two doors, and each of them is going to do something a little bit different. So let's get in here and take a look at them. Alright, so I'm going to maximize my window here. There we go. Let's have a look at these. This cube here, it's a nice little cube. It has an audio source, it has a sound, bubblegum pop sound. Let's hear that. There we go. And go away. We have this sphere here. It's got a particle emitter. It's currently not enabled. And we got these doors. And let's get into each one of them a little bit. So, wanted to be able to just walk up and click on them, but need to be able to click on them first, I guess. So each of these objects has a collider, and what we're going to do is we're going to do raycast from the screen. So we have in the game a first-person controller. It's just a standard Unity object asset that you can import, and on this first-person controller we have included a script which I call Inspector. So let's take a look at Inspector here. The Inspector script is going to run on update because we're looking for input from the keyboard and or mouse. In this case, all of our work will be done with the mouse. We're not going to be doing any keyboard work here. So the first thing you would actually do with any object is click on it with your mouse, left click obviously. So we want to look to see if the left mouse click has happened. And we get that with if input get mouse down 0 for the left button. Then we have to create a ray and then send it to a hit and check and see what that works. Now in this one I have, if the raycast, I gave the third parameter as 3, which is 3 units, the distance away from the first person character at which you can actually click on something. To help identify that distance, also I've included on this first person controller a spotlight that has a range of 3. Glad I caught that. That was wrong. It's green, it's very narrow beam, so that when the light shines on the object, we should be able to interact with it. Also, I have in my canvas, I've included a reticule in the center of this triangle and a dot to show where the center of the canvas is at all times, and so we'll use that as our raycast hit. Now, if we go back to our inspector, we'll see that the vector that defines which direction the ray goes and how far is the screen width divided by half, and its height as well. Now let's say that our ray does hit a collider. Then if we hit this door, then let me get back down here. If we were to collide with this collider right here, what would we want to do? We'd want the door to open, right? If we collide with this cube here, then we'd want something else to happen, and also something else to do with this sphere. What if this door was open like this one? Then we'd want it to close. So we need to differentiate how we're going to interact with these things. Now, all these things have attached to them animations. If you take a look at them, there's animation, door open and close. This one has an animation, cube, which is cube implode. I'll show you that in a minute. And the sphere has one which is explode. So let's have a look at those three animations here. This one right here, animation. Control 6 shows my animation window. Went over to the other monitor. Let me bring that over for you. Okay. So we see that we have here a sphere with rotation and scale animated. If we run along this timeline by just dragging our mouse, we'll see it's bigger and spins. And then what? We want it to explode at some point, I would hope. I mean, you can't just keep blowing up before you explode. So what there is also inside of this sphere is, at the same location, I have to say, a particle emitter, which is going to emit some particles. But how do I start it? It's currently not started, as we saw earlier in the scene description. Well, we have here an animation event. We can edit or delete. I want to edit this one. And what I've done is define a function on explode me. Now, where did that come from, you might ask? Well, let me tell you. It's right here. Sphere, on activate, script. And it's simply one thing. There's a particle system that we want to interact with once we do that. And this void right here, on explode me. It's public so that it can be accessed. And what it does, enables the particles system to emit, tells it to emit, and then it destroys the game object, which in this case is the sphere itself. So the sphere goes away, the particle emission comes into play, and it's as if it exploded. It's a cheap but effective device. So if we go back to the sphere and we look at its animation again, if we just hover over here, this should just say, yep, on explode me. So now this animation, once it reaches its end, this event will be called in the script, which will do these things. So it's kind of like a timer in a sense. This cube, not the audio source, the cube, also has an animation, and it has an audio source. Now let's take a look at this one. If this one we want the audio source to play as soon as you start the interaction, and we also want it to play until a certain point. Let's have a listen to that audio source. I'm not sure if you heard that or not. I'll try to copy that in if I didn't. Back to our cube, and let's look at the animation for this one. Now, on this one we have in our script, we'll go to our script also, cube implode. We have the audio source that we've defined already. Is this one attached? And we have just two voids this time. The first one at the start of the animation, which starts the audio source to play, and I've determined that the time between the start of the audio and the pop sound was 48 frames. And so then the cube will rotate based on its rotation and scale. And let's move this up out of the way a little bit so we can watch this happen. Shrinks, 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 implodes, and then goes away. Destroy game object, and you'll see it fall off the hierarchy. So those two things, we just want to play their animations. Simple enough. This door is different though. If we look at this door here, just the door, which is part of the entire model but is separate out, it has an animation, door open, close, and if we watch its animation, There are no events associated with it. It just opens and closes. And yes, I realize the hinge is in the wrong spot. This is a free model for tutorial purposes only. So if the door is closed, we want it to open, but if it's open, we want it to close. And those seem like two different states for the same object, but it's not the same as these two, the square and the sphere, the cube and the sphere, because these two just have an animation that's going to play and then they're gone. This one's going to stick around and it's going to have to change between one state and the other. The question we had was, how do we maintain these different kinds of states and different interactions with different objects? And realized pretty quickly that tags were the answer. This sphere here has no tag. That's a particle system, sorry. The sphere does, and it's called interactables. Look, the standard ones are untagged, respawn, finish, all the way down through game controller. I've added interactables, closed door, and opened door. And I think you'll understand why these two are here. In case you wanted to add a new tag, you just click add, and click the plus button over here. This is a new tag, and that doesn't actually take place until you click off, come back, you come back to your object, and now you can change this as a new tag. You can tag it there. Tags are strings. They are attached to the game objects. They put game objects in groups. So if game objects aren't the same, like the cube and the sphere, they have different reactions, but they're both something you can interact with just by clicking on them, so they're both interactables. This door is also something you can interact with clicking on, but it has two different states, so now we have, it can be a closed door or an opened door. Right now this door is closed. Let's set it there. So how do we interact with all these things? Well, we go back to our first person controller and we have the script inspector that we've attached, and inspector does all the clicky stuff for us. And let's look at the code for inspector. As a matter of fact, let's look at it in MonoDevelop. A little bit easier to read. As before, I said we cast array, we see how far out it hits, and then what we get back, the hit, is a collider. It hits a collider. An object without a collider cannot be hit by a raycast. So if it's just a texture or something you've got in the scene that you can walk through, then it would never be raycast hit. So the hit has a collider. That collider has a game object, and every game object has a tag which you have set in the editor. So the first thing you want to do is get that tag out, and we want to do something based on what that tag is. I chose enumeration and want to convert it to an integer, and then I'll switch based off the value of that integer. The reason I did that is so I wouldn't have the possibility of falling through and doing something I just did something to. So I assign it to an integer based on the tags. Untagged is the default tag for any object in Unity. I have a closed door tag, an open door tag, and an interactables tag. I just have three objects. Two of them have just point and click interactions, and then the door has states, closed or open. We also want to know, we don't have to know the name of the animation or anything like that. We don't have to set this. We can do this dynamically every time. The great scripting geniuses at Unity gave us get component, so we get the animation component from that hit game object. We also need to know the clip's name. Not for every interaction, but we'll go back in a minute. So the first one I want to do is interactable. So we've given that tag value 3 here. So once we switch, we'll be in case 3. That is, do the interaction and play the animation. So simply we got the animation from the collider, from the raycast. We got its name. We don't need it now. We just want to play it. So if we go back into our game and hit play, we now have that our reticule stays in the center of the screen. We have our green dot. That means we are within reach. It's animation played. If we watch down here at our console, it said do the interaction. Walk up to our sphere. Too far away. There we go. And it explodes, just as we saw in the animation earlier. Let's come back out. I'm going to go back to our script. The doors. Now, the door has an animation which has to be played both backwards and forward, based on its state, its tag, opened or closed. If it's closed, the animation is built to open it. So we just go to opening the door, case 1. We just play the animation forward, speed equals 1, and play it from the beginning. We also don't need to make sure that we've changed the tag to opened, so that the next time we go to interact with it, it will interact the correct way. And that's down here in case 2. Note that this time we are adding a line to set the time of the animation. And that set to 1 is the end of the animation, so it sets it to the last frame before you start to play. So from the open state, it goes to the last frame and stops. At the open state, you need to start at the last frame. Speed is -1. Almost left that there. Speed is -1 to go backwards, and then you play the animation from the end to the beginning. Then you don't also need to remember to change the tag back to a closed door. Let's go back to our game. We walk up to our door now. It opens. And it closes. If we select our door in the editor, and we pay attention to its tag, it's currently closed. Now it's opened. It's currently opened. I can actually catch it midway through. So, there you go. How we use tags and animations to get multiple different interactions from multiple different types of objects in The Lost Door. From Sub-Zero Squirrel Games, I'm Sub-Zero Chuck. Catch you next time.